Welcome to the course on Fundamentals of MIMO Wireless Communication. This is the first lecture, and today we are going to talk about a brief history of wireless communication and give you a brief overview of the things that remain for us to do in this whole course. Today we are going to talk about the evolution of wireless communication systems as it has gone from 1G to 5G. The whole era till today can be briefly divided into three parts: the pioneering era, the pre-cellular era, and the cellular era. The pioneering era is from the period 1860 when Maxwell derived the equations to 1921 when there were first experiments of electromagnetic wave propagation. Then we take a look at the pre-cellular era in the 1921 to 1980. In this period, there was commercial deployment of EM wave propagation into what is known as today mobile communications. After that period, where mobile communications were proven to be successful, we move into the third era, where we call the cellular era. It started with the concept of cellular systems, which was initially developed in Bell Labs. What is not given over here is the last era as of now, which is going beyond cellular, or which is cell-less architectures. We will remain contented within these three eras because the cell-less architecture is still evolving and it is not yet known what kind of architecture is going to come up. So probably in future courses you might come to know about the modern cellular systems or the modern radio access network. The pioneering era begins with Maxwell developing the fundamental laws of electromagnetic waves. So we have a whole list of people including Heinrich Hertz, Nikola Tesla, Alexander Popov, Acharya Jagadish Chandra Bose, and Guglielmo Marconi who were demonstrating these experiments. So if we take a look at how things were, when Maxwell developed these set of equations, it was first published around 1865. If we look at these equations, what we can see that if E field, that is the electric field, is changing at some point, then the magnetic field has a circulation. Also, it can be considered as to forming closed loop linking the electric field. It is also true that if the E field changes with time, then the magnetic field will also change with time, although it is not necessarily in the same way. If we note the next expression, what we find that the second expression tells us is the change in the magnetic field produces electric field, which forms closed loop around the magnetic field lines. So therefore, we are back to our first hypothesis, which talks about the changing electric field, but this field is at some distance from the original disturbance. The velocity of the disturbance is the speed of light. This has been well investigated and available in initial course on electromagnetic theory. So clearly what we see is that there was hints that a change in electric field could propagate through a medium to a distance, and what was discovered is the speed at which things propagate is the speed of light in free space. Moving on to further, what we have is the experimental setup which Heinrich Hertz used. What I have given below is a YouTube video link which really demonstrates in a nice way how this experiment was performed. What he had done was used an oscillator as indicated by the mouse pointer here, and he had used a spark plug or a spark gap in between where there used to be occurrences of spark due to the oscillations. He used a resonator as a receiver where he further had a gap, and he believed that if there was spark over here which would cause change in electric field and thus change in magnetic field followed by change in electric field, which would propagate to the receiver and would induce small current into this loop, thereby causing sparks to appear in this tiny place as can be in this region. What he had experimented was when this distance in the first experiment was around 2 meters, he could see sparks coming, and was a proof that electromagnetic waves do propagate in medium. I would recommend seeing this video, it is very nice and you could get a feeling of how the experiments were performed. Moving down further, we have the next list of 3 people, the first being Nikola Tesla. He was one of the scientific genius who invented many things, among which well known are Tesla coil, and at that time around 1893 he proposed teleautomation, where he was demonstrating radio controlled boats. He was mainly interested at a point of wireless power transfer, which is almost a reality today. He was one of the pioneers of introducing the AC induction motors. So, Nikola Tesla around 1893 did one of the first experiments where energy could be transmitted from one point to another via electromagnetic waves. Following him, there was Alexander Popov. He did his experiments around 1895 and he presented a paper on wireless lightning detectors that he had built using the coherer. The coherer was a famous part of the receiver which is used by several people including Marconi. Around that time in 1894 in Calcutta, scientist Jagadish Chandra Bose, he demonstrated radio waves in the town hall Kolkata. One of his biggest contribution in that era was millimeter waves and the concept of semiconductor junctions. In his demonstration, he ignited gunpowder and rang a bell at a distance. It is often thought that Professor Bose was 60 years ahead of his time. Moving further, we have Guglielmo Marconi, who demonstrated radio telegraphy and showed that radio communication could be used to send messages across the Atlantic across 2,200 miles. This thing became even more important with the sinking of Titanic, where radio signals helped save a few lives during the tragic incident. Thereafter, it became even more important, or the importance of radio wave or radio communication became very, very significant after that tragic incident. As we move down further, the next very important milestone was in 1948, where Claude Shannon produced the mathematical theory of communication. It is often known, or he is often called as the father of information theory, which changed the way we look at communication systems. In our course on MIMO communication, we will use quite a bit of information theoretic results to derive the capacity limits of MIMO. With this, we move on to the 1921 era, or the second era, which is pre-cellular, and what we see is that there were initial deployments of homeland security, that is, it was used by the police department as it is necessary. In that period, there was widespread use of car mobiles. However, these were not connected to the public switched telephone network. These networks more or less operated independently. There were problems regarding handoff, and there was limited zone of coverage in this region. Around 1940, during World War II, there was huge stimulus to the radio communications. There was huge growth in development of handheld devices using semiconductor transistors and so on. So, thereafter we move on to the next phase which is beyond the 1980s, which started with the deployment of analog cellular communication systems. The analog cellular communication systems were followed by digital cellular communication systems, and then there was the future public land mobile telecommunication systems, and finally IMT 2000, which led further in 2010 the adoption of IMT Advanced, which uses OFDM as is mentioned. Beyond 2010, as of now, we are seeing deployments of 4G systems as well as active work is going on for 5G systems. If we look at the timeline, how things have evolved, initially we see that there was the 1G system, which is around 1970s to 1980s period. Fundamentally, it was for analog communication, and there was voice was the main deciding factor or the design factor. there was no data communication supported using this system. Then as things moved on, things wanted to get improved. We go on to the 2G system or the second generation system. The second generation system is characterized by digital voice. So, the biggest difference that we see is digital communications. However, voice still remained as the most important traffic that is to be carried. While things were going from 2G to 3G, there was a period which is sometimes referred to as 2.5G, where data was introduced to be carried over mobile networks. Systems which you were aware of, such as GPRS, Edge, etc., were introduced, which would carry data within the same channel as the signals to be which were carried used to carry the voice signals. Around in the period of 1990 to 2000, 3G was developed and the deployment of 3G was happening in the early period of 2001 onwards. There it is of course a fully digital system. However, it introduced separate paths for voice and data. If we compare with what happened in the previous system in 2.5G, there data was carried within the voice channel, whereas in 3G systems there are separate path for voice and separate path for data. As things improved and people became used to data service, or the need for data service became more and more important, especially with the use of widespread use of internet for all purposes, right from entertainment to scientific and administration purposes. There was more and more demand for data centric services. Because of this, when things moved on to fourth generation mobile communication system, it became fundamentally data traffic oriented. To such extent that 4G was all IP, as will be seen later, is all IP. It was primarily designed for data, and voice could be carried as voice over IP, also known as VoIP. Moving further, today we are in the era where 5G is getting developed. Amongst many things which are moving towards the direction of 4G, there have been development of small cells, there have been development on device to device communication, self organizing network. Some of the important things which 5G is expected to see is millimeter wave communication and massive MIMO, amongst others. What we see is when things moved to 4G, it was one of the first experience of wireless broadband systems, where data rates in the order of 100 Mbps were achievable. In this period between 3G to 5G, MIMO communications were introduced into the system, and what we shall see in 5G, there is huge use of MIMO communication systems. 4G systems also use a lot of MIMO techniques. However, there is limitation on the size of MIMO. In 5G, we are expecting a variety of use of MIMO, or that being one of the fundamental technology changes beyond earlier systems. If we look at how these things have grown right from the GSM era to the 4G era, what we see is that the data rate requirement was very low in earlier systems. As data rate was supported with newer and newer systems, new and new applications came up. So, this went hand in hand. There was data rate supported, there was a data service that required higher data rate, more and more users started growing, and this went on and on and on, and today we have moved beyond 4G into the era of 5G in this way, where these data rate requirements have gone beyond 100 Mbps to Gbps range. This picture shows how the 4G systems were started with. If we look at the chart, the x axis talks about transmission rate, the y axis talks about user mobility. Some of the components shown over here are pretty well known to us. If we take a look at wireless LAN system, which can be described by the 802.11a or G standard or HyperLAN or MMAC, it supported tens of Mbps. However, it is mainly for stationary or movable nodes. As we move towards the mobility axis, we have 3G systems which clearly provides a huge support for high mobility, but at the same time there is low data rate support. So, at that time the target for 4G was set that it should be high in mobility and high in data rate. So, if you look at this diagram, it shows its presence over here, and therefore, the target to be achieved in 4G systems was high data rate under high mobility systems, and that was quite achieved in such systems. If we move on this particular slide, of course, I should put a disclaimer that this is internet resource. It is available at several places, namely Metis as well as Ericsson and other places. So, I have used this internet picture to show the 5G scenarios and requirement. What we see over here, 5G is distinctly different from 4G in the sense that there are a wide variety of requirements coming up. There is a wide variety of requirements coming up, and they could be summarized as amazingly fast, that is how the description is, great service in crowd, best experience follows you, super real time and reliable connection, ubiquitous communication. The ubiquitous communication would mean Internet of Things, machine to machine communications, where millions and millions of devices would be connected. There is another very important scenario, which is the dense urban information society. Under this, it is expected there is a huge density of users would be present in a small location. There would be also requirement of services where delay and reliability would be very, very critical. For example, industrial applications. There would be always the requirement of bit rate, but along with this, there would also be requirement of support for many simple devices. There would be requirement of coverage. Whereas, if you see in 4G, one of the most common things that was running through all the systems was requirement of high data rate systems, high data rate communications. If we move further, the requirements of 5Gs could be specified in this way, where we have the peak data rate requirement in terms of gigabits per second, moving beyond IMT 2020 or moving beyond IMT advanced. The inner circle is IMT advanced, is IMT 2020. It is several times more than the Gbps or the peak bit rate supported by IMT advanced. By IMT advanced, we mean basically 4G systems. User data rate moving from tens of Mbps to hundreds of Mbps. The difference between peak and user data rate can be summarized as peak data rate is the sum of user throughput within a cell or supported by an access point, whereas user data rate is what one particular user would experience. Spectral efficiency is expected to be several times more than that achieved in IMT advanced systems. It is expected to provide higher mobility support. It is expected to provide reduced latency to support real time systems or cyber physical systems, huge increase in connection density from in order of 10 to the power of 5 to 10 to the power of 6. Energy efficiency is one of the other important aspects of 5G systems. Area traffic capacity, which is defined in terms of bits per second per meter squared. So, these are some of the important performance metric by which 5G systems would be measured. If we look at the timeline of broadband technologies, things have been developed from 2000 to the period of 2015, where activities of 5G systems have started to grow. If we take a typical look at how things are developed or how these particular standards are developed, what we see typically there used to be a 10-year cycle from the time the goal was set to work on a particular technology, and by the time the standardization would happen, there would be implementation, trials, and finally deployment. However, what we see today, this 10-year period is getting reduced to periods of 8 years, 7 years, and sometimes even people say it is in the period of 5 years, which is really short. And if we look at the number of changes that are happening is really great compared to earlier systems. Moving on further, this particular slide we summarize the technology changes that have happened from 1G to 4G. We do not summarize what is there in 5G, because 5G is not yet clearly defined, it is under development. So, we hope that around 2020 we would get the final specifications and technology solutions of 5G. If we look at 1G, we see it is mainly analog and voice, as it was said. There were some of the systems, one of them was AMPS, which is widely known. There was introduced the technology of FM modulation, which is high resilience to noise. Cellular concepts were also introduced, and hard handover concepts were also introduced. Now, some of these concepts were very critical in the success of cellular communication in today. We see these knowledge have been extended right through to 4G systems. Next, we take a look at the 2G system, which is again digital as well as voice. GSM, PDC, IS-95, which are CDMA based systems, were used. GSM and PDC, we see they were time division multiple access systems. There was of course digital modulation, there was error correction coding, there was data compression, soft handover, and voice quality. So, if we compare the changes between first generation and second generation, there were significant technological developments that have happened in that period. As we moved further, as said earlier, there was voice and data which were introduced. However, the data was carried within the voice channel. No separate channel was available for carrying data. As we moved further to 3G, data became one of the important things, and multimedia services gained prominence, and there data rate requirements were being written down for one of the first times, where initial targets were 2 Mbps. Moving beyond 3G, or sometimes also known as 3.5G systems, there we see high speed packet access and other systems where tens of Mbps of data rates were achieved. They used wideband CDMA, bandwidth of 5 megahertz. Sometimes OFDMA is also called 3.5G systems, where LTE for instance is also known as 3.9G, and LTE advanced is called as 4G systems. In 3G systems or beyond 3G systems, we will see some of the very important changes that have happened beyond 2G, in the sense channel state information were being used to transmit data to multiple users, whereas in 1G to 2G it was mostly static link adjustments. In 4G, the major difference between these systems and 4G is what we saw, as there was access to frequency granularity. There was guaranteed QoS support, there was adaptive air interface, along which there was heterogeneous networks. Now, heterogeneous networks was supported in 4G, however, later it was also supported in 3G systems, for instance in the form of femtocells. If we look at the data rate that was supported by the systems, what we see is the data rates ranged from a few kilobits per second up to hundreds of Mbps, and 4G systems are a reality today. If we now take a look at the 2G, the important components of 2G were narrowband communication systems, Gaussian minimum shift keying was used, maximum likelihood sequence detector was used, time division and frequency division multiple access and FDD systems were used. In 3G, the major differences were 5 megahertz bandwidth moving beyond narrowband systems. There was code division multiple access, there was rake receiver, there was multi-user detection, QAM or quadrature amplitude modulation, and high speed packet access systems. Also, interestingly, we see that MIMO signaling started to appear in 3G systems. It appeared as beamforming, which could also be used in multi-user detector. It also supports spatial multiplexing as well as precoding control information by feedback, or what we have in modern days notation closed loop MIMO. So, when I mean 3G plus, I actually mean WCDMA plus HSPA, not limited to just WCDMA systems. If we look at the main components of 4G, again we see the prominence of MIMO techniques coming into picture, along with frequency domain link adaptation or frequency domain radio resource allocation. So, these two together formed the major gain provider of 4G systems compared to earlier communication systems. What we see over here is adaptation is one of the major things that was supported in 4G systems. Of course, we have OFDM. This is not to mention because this is so well known today. So, beyond CDMA, the transmission technology was changed to OFDM based or multi carrier based. And somehow this OFDM had a natural affinity to support MIMO communications. So, everything was as if in place for 4G systems. If we move further, we move on to what is going to appear in 5G. 5G, there is a consensus it will be a network society where everything is going to be connected. Some of the important technical solutions that are going to appear in 5G are as listed here, and what we see as identified some of the technology enablers for 5G are massive MIMO and millimeter wave amongst others. So, if we summarize at this point, what we see is that MIMO communications have been one of the most important techniques which have been providing us with higher data rate as well as giving quality of service. MIMO communications have been introduced in 3G systems. It is there predominantly in 4G systems, and what we find in 5G system, one of the most important or early versions of 5G systems that we are expecting to see would be supporting massive MIMO communication, and hopefully there will be millimeter wave to go along with massive MIMO, which appears to be one of the enablers. So, what we can say is that MIMO communication techniques, what we are going to learn in this particular course, is very pertinent and very important, which will provide significant development in the technologies that are present, are going to come, and hopefully many more new things that will happen in future. Thank you.